Any more questions?
No,
No
sir.
questions? Okay, today we are going to do another example of CLR1 and LLR1. Okay, so let's take the homework problem and try to find out uh, the CLR1 and LLR1 percent. So what is our homework problem? What is our homework problem?
Sir, second up.
Second, what is the grammar?
S derives AA.
If you say SD, that's A, I cannot understand actually. What
S
is
derives capital A, small letter
SD rise, capital A, small letter A, then
A. Capital A derives
capital A derives
capital B, small
capital
c.
capital B, small c, then
Capital B or slash capital B
capital B, then
slash S.
slash
Capital S.
capital S. Okay, then
Then capital B derives
capital B derives
small letter b
small letter B,
slash epsilon.
small letter B slash epsilon.
Yes.
This is the and what is the stream? We have two parts.
So capital C, no, sorry, small c, A.
Small c, 3A.
3A, small letter, yes.
All right. Okay. Example of CLR1 and LA. Okay, so what is the first step we need to do? What is the first
Augmented,
augmented product?
augmented row.
So S dash derives S. Now let's start from here. S dash derives dot S. What would be the look ahead? Dollar. Then S derives dot A, capital A, small a. What would be the look ahead? What would be the look ahead?
So dollar.
You add this product because of this S, just after this S. So first of that,
Dollar.
so dollar. Now you have to add A derives dot B C or dot B or dot S. Okay. Now what you are going to do? What will be the look ahead? Just you add this product because of this A. Just after this one, this is there. It's the first of this. So A. Now again you have to add B. B derives B or epsilon. What would be the look ahead? For you added this product because of this B. So what is just after B? C. So C. Then again here, what is just after B? What is just after B in this case?
So
Then
nothing.
nothing.
No. What is this
Dollar.
actually? Why dollar? If you like write this way, it derives. This is the shorthand of something. BC BS. What is the meaning of this? It is nothing but three product. A derives dot BC A, A derives dot B A, A derives dot S A. This is the same thing like this. Do you agree with me or not?
Yes, yes, sir.
So it is the same thing. So we have to write here C oblique A.
A.
Then we're done. Again,
Right.
S is there. Now we have to go back again because this time the look ahead might change. So what you are going to do is derives, you have to write again dot A or A, comma A. Then what happened? If you write again this thing A derives dot BC dot B dot S, you are coming back to this product. So you can stop over here. Did you get it? But this product must. In LR1 items, you have to write it again. All right, guys?
Yes, sir.
Okay, so let's continue. Moving on S, what do we get? We get S dash derives S dot comma dollar and A derives S dot comma A. We are done with this. আচ্ছা একটা প্রোডাক্ট বাদ দিচ্ছি সেখানে হচ্ছে এটা ডট বি ইট ইজ ফাইন বি ডট epsilon b dot epsilon what is this it is very important b dot epsilon what is this Tell me. What is the meaning of this yes what is the meaning of this guys please tell me don't keep silent what is the meaning of this b derives dot epsilon so just after dot there is nothing epsilon so it is nothing but b derives epsilon dot and it is nothing but b derives dot so these three are same thing it means whenever just after closure operator if there is epsilon it becomes the final product of b derives dot did you get it
Yes, sir.
so remember if after closure operator there is epsilon it means after closure operator there is epsilon means after epsilon there is a closure which is nothing but it is a final product and it is nothing but b derives dot we represent by this that means there is a null right hand side too from a null right hand side we can derive to left hand side that is the catch so it is important did you get it this is the meaning of this now move on A, what do you get? Move on A, what do you get? S derives A dot A, what is the look ahead? Dollar and here S derives comma A. Okay? What's next? That then tell me. Guys, what next?
So go to on B.
Go to on Let me check one. Oh, it's fine. It's fine. Tell me.
Go on capital B.
A is done. Go to capital B. Go to capital B. What do you get? A derives C and A derives B. Dot. Then look at is A. Then look at is A. We are done with this. The B is done. What else? A is done. B is done. Small b. So B derives B dot. We are done. We don't need to move on epsilon because it is already become a final product. Okay. So you can also cross out this epsilon. All right. So let's number this. This is 0 and it contains final item. This is 1 and it contains final item. This is 2, it does not contain final item. This is 3, it is containing final item. This is 4, it contains final item. Now move here, it is done. It is done. It is we have done. So move on A, we get SD rice, capital A, small a, comma dollar, SD rice, capital A, small a, comma A. Now it is done. And we have shift on small c. So A derives B C dot and we are done. So here we have final item. Five, six. Now this is the state transition diagram. Okay. Now let's draw the table. How many states are there? 0 to 6. Zero, 1, 2, 3, 4, 5, 6. Action. Go to. Action is on A, B, C, A, B, C, dollar on S, A, B. Yes. Now fill up the table. Fill up the table. So 0 saying S. Why should I go?
1.
State 1. 0 saying A. Why should I go? State 2. 0 saying B. I should go to state 3. 0 on B. Shift 4. Now 1 saying dollar accepted. 1 saying dollar accepted. And 1 saying A. So let's write the rule number. Rule 1, Rule 2, Rule 3, Rule 4, Rule 5, Rule 6. And S derives. S derives. After going to state number 1, A derives S. So it is what? It is which rule? Rule number 4. So here would be rule number 4. Alright?
Yes, sir.
Got it? No, got it. Okay. Now let's go to state 2. State 2 on A. State 2 on A, we are going to state 2 on A going to shift 5. 2 is done. 3. 3 on C going to shift 6. And 3 is the final item. So what is the rule? Rule 3. Rule 3. So rule 3. Now let's go to state 4. It's the final item. It's rule 5. And what would be the look ahead? I missed the look ahead. A. So look at would be
A.
4A rule 5.
Rule 5.
Now 5, what is 5? 5 we have same product but to different look at. So we have to write it both places. What is the rule number? Rule number 1. On A, rule 1 and dollar, rule 1. And 6 is the final item. What is the rule? Rule 2. Why should I write? Is the SLR1 and CLR1 table same? Are they same? Are the same? Let's open that one.
No, no.
Let me see. CLR1, I have already solved that in homework. Oh, I missed one of the product. So let's fill up the product first. I think I missed rule 6. So rule 6 would be state 0 and it would be on A and C. It should be on A and C. Right? A and C. So rule 6, rule 6. Okay. Now just check that. Check the.
Yes, sir.
Same. Are the same?
Yes, yes, sir.
Let me see. R6. R6. Okay, it is a special case where actually it is same. It is a special case where it is actually same. But oh, maximum times, whenever CLR is more powerful, the table becomes shallower. But in this case, it is absolutely same. Now, how can I parse? So, let's create a stack. This is the important part. So, we start from state 0. And we are drawing the, let's say, yeah. This is my C, A, A, A. Finally, at the end, there is a dollar. Now, see, look carefully. Look the movement. 0 seeing C. 0 seeing C. What is the thing? What is the entry there?
Reduce 2.
Reduce 6.
Reduce 6, sir. Not the
Now, what is rule number 6? This is the rule number 6. Epsilon reduced to B. So, what can I do? Now, tell me, how can I parse? Any idea? So, it says if I have a epsilon, I can reduce it to B. Now, epsilon is nothing. Epsilon means null. So, anywhere we can put a imaginary epsilon. Okay. So, I will put a imaginary epsilon just before the look ahead and I'm going to reduce it to B. Did you get the point? It is very important. Now, how many entries I have to pop? The length of epsilon is nothing but 0. So I do not need to pop anything. Did you get it?
Yes, sir.
Now I have to push B. I'm going to push B. Now, what would be the new state? 0 seeing B. 0 seeing B should go to state number 3. So this is the important part. I have taken this example to show you 2 points. One is actually what happened for the epsilon product. That is the one point. And second thing is whenever there is this kind of rules, B deducts to epsilon. When I read to reduce from epsilon to something, what we are going to do? So in that case, we can consider a imaginary epsilon and then we can convert that right hand side epsilon to left hand side. So that is the thing. That's why this example is important. Now 3 is saying C. 3 is saying C. What is the case? Shift 6. So I'm going to shift C, small c. I'm going to state 6 and move the loop ahead. Now 6 is saying A. 6 is saying A. What is the case?
Reduce
Rule number 2. So what is the rule number 2? BC would become, so this C and B would become A. So how many entries I have to pop? 2. 2 start 2 equal to 4. 1, 2, 3, 4. I have to push A. Now 0 saying A. Why should I go? 0 saying A. I'm going to state number 2. Now 2 is saying A. 2 is saying A. Shift 5. A, 5. Now 5 is saying A. Reduce using rule number 1. So what is rule number 1? A derives S. This A and this A would derive S. So how many entries I have to pop? 4. 1, 2, 3, 4. S. 0 saying S. 0 saying S. I should go to 1. Now 1 is saying A.
Small
A.
So rule number 4. What is rule number 4? S would derive to A. So this would be S would become A. How many things I have to pop? I have to pop 2. Because right hand side is 1, start 2 equal to 2. Now I'm going to push A. Now 0 is saying A. Why should I go? 2. Now 2 is saying A. 2 is saying A. I have to shift. So A, 5. I'm going to move the loop ahead. Now 5 is saying A. 5 is saying A is rule
1.
number 1. So this A and this A would become S. So I'm going to pop 4. Push S. 0 saying S. 0 saying S. I'm going to state number 1. Okay.
Yes, sir.
Now 1 saying A. 1 saying A. Rule number 4. What is rule number 4? So A would derive, S would derive to A. Now I have to pop 2. I have to push A. 0 saying A. 0 saying A. I should go to
2.
2. Now 2 is saying again A. 2 is saying A. Shift
5.
A going to 5. Now 5 is saying dollar. 5 is saying dollar. 5 is saying dollar. So reduce is in rule number 1. So what is rule number 1? This A and this capital A and this small a would become S. Finally, I have to pop 4. 1, 2, 3, 4. I have to push S. 0 saying S. 0 saying S. I'm going to state 1. Now 1 is saying dollar. 1 is saying dollar. That's it. This is the case. Okay. That's why I have taken this example. Very good. Okay. Do you have any question? You can ask me. Otherwise, I can leave from there. Any question, guys?
No, sir.
No question. Okay. So let's start new topic today. That is called SDT. Oh, before that one, I have to make the conclusion. So let's make the power comparison. This is a gist. Power comparison. What is the least powerful parser in bottom up?
LR 0.
LR0. The more powerful is
LR 1. SLR 1.
SLR1. Then এটা হচ্ছে more powerful হচ্ছে LR1. And এটা হচ্ছে powerful হচ্ছে CLR1. What is the conclusion? Tell me. Language comparison. So language of LR0 is a subset of language of SLR1 is a subset of language of LALR1, and it is also a subset of CLR. This is the language comparison. What is the catch? What do you understand by this? Whatever you can do using LR0, you can do with SLR1, LALR1, CLR1. But there are some languages which cannot be do using LR0. So if you can do that with SLR1, definitely you can do with LALR1 and CLR1. Did you understand the concept?
Yes, sir.
So power. If something is possible to do using least power, it is also possible to do more power. But there are some languages which cannot do using the least power, but it can do with more power. Okay, and there are some unambiguous languages. There are some unambiguous which cannot parse using CLR1 image. So that is the shortcoming of humans. That is the shortcoming of humans. So there are some ambiguous languages which cannot be parsed. We cannot use those actually. Though the grammars are unambiguous, but our method is not powerful enough. So even using CLR1, we cannot generate parse tree. All right. So this is the end of parser part. If you have any query, you can ask me. Okay. Otherwise, I should start new topic. Any topic, anything you want to discuss? No? Okay. So should we start the next part?
Yes, sir.
Okay. And another thing is, as the uh, uh, as the number of states in CLR1 and number of the states in SLR1 are same, so it is also LALR1 percent. Nothing too much. It is also LALR1. So it is CLR1 plus LALR1, but plus SLR1, all three is percent. Okay, now let's start new topic to a new topic of today, that is called synthesis directed translation. Synthesis directed translation, or SDT. Now, what is SDT? Let's take a grammar, our very favorite, very familiar grammar, the calculator grammar. E derives E plus T or T. T derives T star M or M. M derives number. What can it do? What can it do? Tell me. Let's say I have given this calculation. 2 plus 3 star 4. Can it compute this thing?
Yes, sir.
How? How can it compute this thing? How can it compute this thing? if you have this grammar and parse table, what can you generate? You can generate parse tree. But using parse tree, can you compute? Using parse tree, can you compute this? How can you compute? Tell me. Yes, yes,
So E derives A plus T.
yes. No, no, wait, let me tell. When you in the parse tree, what is this plus? In the parse tree, what is this plus? Is it really the operator or it is like a character? What?
Sir, a character.
It's a character. So you don't have any meaning in the parse tree. What is plus? It's a character, part of the string. Now, how can you actually do the action only using parse tree? Is it possible?
No, sir.
So it is not possible.
What do you
So
mean by actions? Like, if we get this kind of symbol, we're gonna do that. Right?
no, just think about this. We have this grammar and we have parse table. Then we can definitely create a parse tree for this. We can definitely create a parse tree for
Yes, sir.
this.
Yes.
But only using parse tree, how can you actually find out the output? The output is actually here for. How can you generate the output? How can you calculate the output? Is it possible?
Not possible because we didn't give that algorithm any semantic.
Good, good, very good, very good. So you understand. So to compute 2 plus 3 star 4, we need more than parse tree. We need we need some action level. Okay. So this action is also called semantic rule. Okay. So so parse tree plus action or semantic rule. What is the meaning of semantic rule? What is the meaning of semantic rules? Can you tell me? Semantic means meaning, giving meaning to together. This thing is nothing but SDT. So whenever there is a parse tree, we should say not parse tree, there's a grammar. Whenever there's a grammar plus action or semantic rules, going to give the meaning to grammar. Together, it is called SDT. So instead of only writing that grammar, if I write like this, E derives E plus T or T derives T star M or M derives নাম। এবার দেখেন look, we already know how to give action because in the lex and yak part we have given action. Am I right? In the lex and yak course
Yes,
I
sir.
have given action. So same thing. So in this case, what would be the action? The action would be like this. M dot L val is equal to num. Here, what is the action? T dot val equal to M dot val. Here, what is the action? T dot val is equal to T dot val star M dot val. Now, what is the action here? E dot val is equal to T dot val. And what is the action here? E dot val is equal to E dot val plus E dot val. So this is the grammar part. This is the semantic rules. Together, it is called SDT. Now, how it works? How it works? So let's take that string. We don't know how to write this semantic rules, but somehow consider this is correct. Now let's take that string. What is the string? 2 plus 2 plus 3 star 4. To draw the parse string. 2 plus 3 star 4. And we know how to draw the parse tree. So what would be the parse tree for this? What would be the parse tree for this? He derives
He derives E plus T.
E plus T, then this E derives T,
T derives
this
T
T derives
star
M, this M derives num, this T derives
T
T
star
star
M.
M, this T derives M, this derives num, M derives num. And finally, this num is nothing but 2, this num is nothing but 3, this num is nothing but 4. Now see the magic. So this is the parse tree. Now go. Traversing like before. Top to down, left to down. So we encounter here 2. So this num is nothing but 2. Then we encounter a reduction. Num is reduced to m. The num is, so this is the product. Num is reduced to m. So what is the action here? What is the action here?
reduce.
M equals to 2.
Forget about this. So m, this is the reduction. This num is reduced to m. Num is reduced to m. So what is the action? Just after reduction, we are going to do this action. So what is the action? M dot val become num. Whatever the value of num, that would be stored on m dot val. So let's create a m dot val, and here we stored the value. Did you get the point?
No,
Yes,
sir.
This, whenever we're traversing this tree, this num, we encounter this num, then just upper level we encounter m. So this is a reduction. Am I right? এখন যদি মানে মিড টার্মের আগে জিনিসপত্র খেয়ে ফেলেন তাহলে তো প্রবলেম। What is parse tree? Back to origin. What is parse tree? Tell me. তো স্যার বললো কে? মই মেয়েটাকে প্রশ্ন করছি। স্যার, ও স্যার, হ্যালো ম্যাডাম, হাই ম্যাডাম, can you listen to
Sir,
me
I
guys?
cannot see your like video properly. I think it's
Everybody has the same problem.
No, sir.
Everybody is saying, why you are not seeing the face? So let's continue. So again, the same way we were traversing the first tree before, this time also we are traversing the same way. So top to down, left to right. So initially we got 2. Then just above this 2, there is a num. So this 2 would be the value of this num. Then this num becomes m. So which product is this? This is the product. This num is becomes m. So what is the action? M dot val become whatever the value of num. Whatever the value of num. So you can say this one is num dot l val. So in this case, num dot l val is nothing but 2. So m dot value would become 2. Then we continue. Then this m is derived to t. So this is the product. M is derived to, sorry, m is reduced to t. So this is the case. So t dot val associated action is t dot val would become m dot val. So t dot val would become 2. We continue. Then t dot val, t reduces to e. So this t is reduced to e. So what is the action? T dot val would be assigned e dot val. So e dot val become 2. Now plus it is not reduction. We continue again. Now we again got, so this now would become 3. Again we got this. So m dot val, it would become again this same product. So it would become 3. Then again t dot val. So it would become 3. And star, it is not reduction. We go back again. So this now would become 4, but m dot val, this would become the same product. It would become 4. Then yes, this one is a reduction. T star m reduces to t. So t star m reduces to t. So this t has a value now 3, and this m has a value of 4. So what would be the case? T dot val would become t dot val star m dot val. So it is nothing but 1. And finally this one, e dot val plus t dot val. This is a reduction. This is the case. E plus t reduces to e. So e dot val is nothing but e dot val, which is 2, plus t dot val, which is 12. So the final answer will be 4. So this is the case. Did you get it?
Yes, sir.
So this is the case. Now, if you feel uncomfortable, some people. So left hand side and the right hand side, there are recursive term, then they put a 1 here. They are not different. But to differentiate the different instance of same variable, sometimes they write this lines. So here also, you can write. So then it will become more unambiguous. So this is the movement of SDT. Using only SDT, you can actually find out the output, not only using the graph. Okay, now what is this called? E derives E plus T. What is this called? What is the name of this?
Sir, a product.
The product. What is this thing? What is this called?
A semantic rule.
A semantic rule. And each of these things, that means like a tag after the variable name. So these are called attribute. These are called attribute. Okay. Now, if you are careful enough, so this is actually the formal way of writing SGT. But in the case of ER, if I want to write this action, how should I write in EAC? In EAC, how can I write this action? Left hand side attribute is nothing but $. Then you have to count the position. This is the first position, so $1 plus this is the third position, $3. So you understand. So that is the format of writing semantic rules in EAC. So you understand. Did you understand? So left hand side in this case is eval. In EAC it is $. First of the variable is $1. In this case E1 val, and third one is actually nothing but $3, which is T dot. Okay, guys. Any more question?
Sir, can we do our project in PLY?
Yes, you can.
Okay.
You did not start your project yet?
Yes, sir. I've started.
Okay, very good. Okay, so how did we accomplish the this SDT actually? How did we accomplish this SDT? How can we accomplish this SDT? Using top down or bottom up? Come on,
Bottom up.
bottom up. So we accomplish this SDT bottom up ways. Is it possible to accomplish this SDT using top down, top down process or top down ways? It is possible. In that case, you have to write here the actions numbers, corresponding number. So let's write this action as number 1, this one as number 2, this one as number 3, this one is number 4, this one as number 5. Okay, so get the difference. So get the difference. So SDT, one is BUP, another is TDP. In BUP, we do action on reduction. In TDP, we do action when we get the action number. So this is the difference, remember. So BUP is done. We are done with the BUP. Now, how can we do using TDP? So again, please draw the part string. E derives. What is the first one? E plus T. Now also write down the associated action with this. So what is the associated action for this? E derives E plus T. What is the action?
1.
1. So you can write here 1. Then this E derives T. What is the action? 2. Then T derives M. What is the action? 4. Finally, M derives num. What is the action? 5. Then this T derives T star M. What is the action? T derives T star M. What is the action? 3. This T derives M. What is the action? 4. M derives num. What is the action? 5. Then this M derives num. What is the action? 5. Now put the numbers. 2, 3, 4. Alright. Now again we are traversing this tree. But instead of this time, because top-down parser does not use reduction, it uses derivation. So this time, whenever we encounter these numbers, we are going to do the action. Okay? So let's start. And this one is a special type of action. So how can I actually traversing the tree? Again, the same way. Top to down, left to right. Fine. Now start special action. What is the action? What is the action? This number would become 2. This number would become 2. Then traversing again M5. What is the action? What is the number 5 action? What is the number 5 action? M-val becomes num dot L-val. So this M dot val would become 2. Then again go T4. What is the action? M T dot val is equal to M dot val. So this T dot val would become 2. Again move this 2. What is the action? What is the action? 2 is E dot val become T dot val. So E dot val 2 plus no action. Go again. Then star again action. So this number would become 3. Then we go. This is 5. So what is the action? M dot val would become num. So it has become 3. Then go again T num action 4. So T dot val would become 3. Then again move. This is not action. So go over here. This is action. So this num would become 4. Then this is action 5. The M dot val would become 4. Then 3. 3. This is action. So what is the action? T dot val would become, this is the action number 3. So T dot val star M dot val should be T val. So it would become 12. Then finally 1. What is the action? E dot val is equal to nothing but, number 1 action is nothing but E dot val plus T dot val should reduce to E val. What is the action? It would become nothing but 2 plus 12. That's it. So this is the answer. Did you get the point? Any query? Guys, please say something. Are you sleeping, guys? Hello?
স্যার অ্যাকশন গুলা তাও তো নিচে থেকেই যাচ্ছে, রাইট? তো এটা টিডিপি কিভাবে হয়?
এটা তো ট্রাভার্সিং। একটা পার্স ট্রি তো আমরা সবসময় একইভাবে ট্রাভার্সিং করি, বিকজ উই রিড ফ্রম লেফট টু রাইট। Traversing does not change. But in this case, what happened when we are creating the parse tree? When we are creating the parse tree, when we reduce and creating the parse tree, that time we are performing the action. In this case, and in that case, top-down person, we create the parse tree, and then while we are creating the parse tree, we associated the correct action. Then we are traversing again the parse tree. Whenever we get the number of the action, we are performing the action. Did you get the point?
I got it. Yes.
Okay,
yes.
thank you very much. So that is the difference between BUP and TDP SDT. So which one is better? Which one is better? Which one is more faster? Which one is faster? Definitely bottom-up parsing SDT is faster, because we are creating parse tree and we are also performing the SDT. We are creating the parse tree and performing the SDT. On the other hand, in TDP, we have to first create the parse tree, then we have to perform the action. All right, guys. So if you have any question regarding the quiz, you can ask me. Otherwise, I'm going to leave. Any question, guys? Yeah.
No, sir.
Okay, so let's take the attendance. Acha, tell me one thing. How about the next semester? What is going to be happen? What is going to be happen in the next semester? Do you know anything?
সরকার তো বলতেছে খুলে দিবে স্যার।
সরকার বলছে খুলে দিবে, তাহলে আইবিও খুলে দেবে, চিন্তার কারণ নাই।
জি স্যার।
How about the overall experience of online classes, guys?
স্যার ভালোই ছিল স্যার, কিছু কিছু সমস্যা ছিল, বাট এত খারাপ না স্যার।
Overall, I'm talking about overall experience? Should we continue online class or we should stop from next semester?
So overall, I would choose doing classes in IOB other than online.
Okay, so maximum people don't like online classes. I
No,
understand.
sir.
Okay, now it is clear. All right, guys, then see you in the next class. Next class is the quiz. So you know the rules of the quizzes. So again, 6 minutes. This time you will get 6 minutes for each question, 360 seconds. And again, in 3:30 you will come to actually IUB Google Classroom. Then we'll start our server, and you people will participate the exam. So I'm going to monitor it from both, from my computer and from my server, both the same way. So if you have any question, you can ask me. Otherwise, I can leave. No question, guys?
No, sir.